Okay, so here are some supplemental examples to do with section 9.2 in geometry. We only have to do a couple of them because there's not a whole lot to do in this section. Um, so we've got this transformation of vector of negative 2, 4, which again, I kind of treat this as just generally thinking through it. That means 2 left, 4 down. And that's easy to sketch. But the book also has this notation of coordinate notation version, function notation, as they also call it, where it's x minus 2, y minus 4. Okay, are the points. So what basically happens is you have t, u, w, x. And what you do to get your 4 points is you subtract 2 from all the x's, subtract 4 from all the y's. So t prime is at negative 3, negative 3. U prime is at 2, negative 2. W prime is at negative 1, 1. And x prime is at negative 3, negative 1. Okay. So let's see. T was at negative 1, 1. U is at 4, 2. W is at 1, 5. And x is at negative 1, 3. So T, U, W, X. And then in red, I'm going to have this figure and just move it left 2, down 4. But the points I could do that with now. So T is at negative 3, negative 3, T prime. U is at 2, negative 2. Oh, I went to one far over too many here. So that didn't look right. That's not T prime. Here, that's T prime. And then U is at 2, negative 2. U prime is. W prime is at negative 1, 1. And then x prime is at negative 3, negative 1. And all that happens is I took this figure and again move everything left 2, down 4. Or if I look at it from one point to the next, like for instance from U to U prime, I traveled along a vector that was left 2, down 4. And we do that for all of these ordered pairs. Again, all 4 of those left 4, down 2. Or left 2, down 4. Okay. Next example is describing a transformation in the coordinate plane. Now there are two ways to describe it. You can go by vector or you can go by coordinate notation. If we go by vector, let's say, I got to go from 1 to 2. What you have to do is pick two parts that correspond. So like these two guys here, those two corners, this corner and this corner. I'm going to start at 1 and go to 2. So 1 has the end point, the tail, and then this guy gets the terminal point. So if I like this vector, to get from here to here, I've gone right 4, up 2. So that translation vector is 4, 2. Okay. Now if I want to do that in coordinate notation, that'd just be x, y is x plus 4, y plus 2. That's it. Okay. And those are the examples really for section 9.2.